The deep ocean is one of Earth's harshest environments. The main reason why? Immense, crushing pressure. And you can demonstrate what happens when you don't respect that pressure, like the Titan Submersible, at home.
Now entering the facility.
By now you've likely heard of the Titan sub disaster, whether by news or by meme, where 5 men imploded in a much maligned submersible near the wreck of the Titanic. Now, for all the complications of proper submarine engineering, of which there are many, what ultimately ended Titan's fateful expedition that day was relatively simple. Simple enough to learn from and show at home using household materials. But first, some context. The main danger of the depths, aside from a lack of light and near freezing temperatures, is hydrostatic pressure. This pressure is calculated simply as the weight of a column of water above some point, assuming some area like 1 square meter. So hydrostatic pressure, measured in newtons per square meter or pascals, is equal to the density of the fluid multiplied by the acceleration due to gravity, which gives us weight, multiplied by the height of the fluid column or depth. If we're in the ocean and using metric, because it makes more sense, there's an easy rule of thumb to remember here. Since normal atmospheric pressure is roughly 100,000 newtons per square meter, the density of water is roughly 1,000 kilograms per cubic meter, and the acceleration due to gravity on Earth is roughly 10 meters per second, the hydrostatic pressure in the ocean will increase by 1 atmosphere for every 10 meters you descend. Remember this value, because it will be on the test. I told you about the test. I did. I swear those Kevins up there are doing literally nothing all day. It's almost like they're on a loop. The wreck of the Titanic is roughly 4 kilometers deep. This means, dividing by 10 as we just learned, the pressure down there is roughly 400 atmospheres. Now, we live at 1 atmosphere, so that's hard to conceptualize, but imagine this. At that depth, if you took a scuba tank and shot a hole in it, water would rush in and air wouldn't rush out. This is a pressure so high that you either need to be evolved to handle it, or you need to design something to resist it, like a submarine. But even then, being in a place where 6,000 pounds of force is pressing on every square inch of your body can be extremely demanding. More people have been to the International Space Station than have been to the wreck of the Titanic. Hopefully, all of this will sink in with a simple but surprising demonstration that you can do at home and follow along with me. Now, Kevins, go get the soda cans. How are we gonna pay the bills if you just stand there? Oh, wait. Today's video is sponsored by Rocket Money. Gamers. I'm award-winning science educator and furry fanfic prompt, Kyle Hill. You know what? I'm subscribed to too many services I can't keep track of it. TV shows, movies, meals, argan oil, it's all too much. And especially too much when I'm trying to save up from a brand new death rave. That's why I use today's sponsor, Rocket Money. Rocket Money is an all-in-one finance platform that helps you save more and spend less. A personal finance app that allows you to manage subscriptions, lower bills, build a custom budget, and grow your savings all in one place. List and cancel unwanted subscriptions with a single app tap. They do it for you. Monitor your credit. They do it for you. Upload photos of your bill and have them negotiated lower for you. They do it for you. Never get stuck on the phone with Greg from Who Cares ever again. If you want to save more and spend less, go and join the already 3.4 million people using Rocket Money. That's rocketmoney.com/Kyle Hill, or click the link down in the description to get started for free, or you can unlock more options with Premium, that is. That's rocketmoney.com/Kyle Hill to get started for free right now. Hey, it's rocket-powered finance. As we said, you don't need an ill-fated trip to the bottom of the ocean to understand the awesome power of pressure. Right now, 100,000 newtons of force are pressing down on every square meter of your body, which is about 2. Don't ask me why I know the square footage of the human body. It's for skin reasons. There's about 1 atmosphere of pressure pressing down on your body right now, but you don't feel it because you've evolved to not feel it and live as an organism on this planet. But we can show the power of just 1 atmosphere, let alone 400, with a soda can and some water. Here's what you need to do this experiment along with me. You need a tray full of ice water. You need a soda can. you need some way to boil water in that soda can, whether it's a kettle or a hot plate or a stove. We want some eye protection. We also want something to protect our arms from potentially boiling water, like a lab coat or a long sleeve shirt. And finally, we want something to manipulate that boiling hot water can. I'm going to use a pair of tongs. So here's what's going to happen. I'm going to put just a little bit of water in this can. I'm then going to bring that can's water to boil on the stove. Once the water vapor is boiling out of there, I know that it has displaced the 1 atmosphere of pressure air that was in there originally. Then, all in one motion, I'm going to use the tongs to submerge the boiling hot water can, just the top of it, into our ice water. What that will do is simultaneously create a seal, like a pressurized vessel, and it will force the water vapor inside the can to rapidly condense, creating a vacuum and then showing you the power of just 1 atmosphere. Are you ready? Here we go. Get yours at hacksmith. Whatever their suffix is for their website. It's a lightsaber. Once the steam comes, it's time to go. OceanGate example in 3, 2, 1. That is just the power of 1 single atmosphere. You can see what happened. The equalization of pressure caused some water to rush in, which also likely happened in the Titan submarine, killing the men instantly. But just 1 atmosphere of pressure, just 15 pounds per square inch, can crush a can accustomed to 1 atmosphere like it's nothing. Of course, materials here make a big difference. For example, if the Titan submersible was made out of something sturdier and was actually rated for the depth that it went to, then nothing at all would have happened. And we can demonstrate that with a different can. This is a beer can made out of much, much sturdier stuff. The metal is thicker, the ribbing is better, and I'm using this to simulate, well, what if the Titan submarine was made up to the specifications that it should have been made to? We should see some sort of pressure equalization here, but no catastrophic failure. See an interesting thing there? See how the boiling immediately stops and starts? See that? Because once water has a certain amount of energy in it, once it's at a certain temperature, it will only boil until there's enough enthalpy, whatever. Wait for the vapor. Much, much sturdier can that we're using to represent, well, what if the Titan was built just a little bit better? In 3, 2, 1. You see what just happened? What just happened was the can did not implode, but the equalization of pressure forced it to suck in a tremendous amount of water to fill the vacuum that we created, and then it suction cupped itself to the glass. That means that the vessel totally withstood that 1 atmosphere of pressure. All it did was fill itself with all the water it needed to equalize all of that pressure. Now, this isn't an implosion in the same way. If Titan operated like this sturdy can, then nothing would have happened at all. This can didn't fail, it didn't buckle, it didn't break. That is the difference. That equalization of pressure, that's normal. But what's not normal is for your submarine to turn into this. This is the power of engineering in the face of tremendous, overwhelming pressure. If you cut corners, if you try to beat the laws of physics, if you disregard safety concerns, you end up like this instead of this. Like many high-profile engineering accidents over the years, many people saw the Titan sub disaster coming, from safety experts to former employees to even Jimmy Cams. Our best guess for what happened that day Is that a failure in the carbon fiber hull, perhaps delamination because the hull wasn't actually checked and it was made with old materials, or a complete failure of the viewport, which wasn't actually rated for that depth, cause an instantaneous and very violent equalization of pressure between 1 and 400 atmospheres. It would have looked very much like our can experiment, but probably a lot worse. And we know that from other testing we've done on the implosion of objects. Ultimately, it was an appalling lack of safety and safety culture that ended 5 lives that day. You can't put pressure on the laws of physics and win. Until next time.
Now exiting the facility.
Thank you so much to the very nerdy staff here at the facility for their direct and substantial support in the creation of this here video. If you want to join the facility, if you want behind the scenes stuff, if you want videos early, if you want monthly live streams with yours truly and a private Discord, you can click the join button here on this video on YouTube or go to patreon.com/KyleHill and get a silky white lab coat like I had today. And if you support us just enough, you get your name on Aria here in every single video. And as you can see, there's so many of you. How am I ever going to pass the Another little fun thing with that rule of thumb that we learned: for every 10 meters you go down in the ocean with that density, seawater density is a little bit, every 10 meters you go down, it's 1 atmosphere. Well, that's also why there's an actual limit to how far you can suck up a straw. The actual height limit, even if you had a straw that was over 10 meters, water wouldn't go up over 10 meters because the pressure differential is effectively 0 and 1 atmosphere, and that's how much 1 atmosphere can actually hold up. So the ultimate length of a functional straw is 10 meters. At that point, the sucking end forms a vacuum and the water starts boiling, and you don't want a boiling sucky straw. Thanks for watching. You don't.
No.